This is the Indian Brahmos cruise missile. It flies around Mach 2.8 and can carry a 300 kilogram payload, about 290 kilometers. It is mainly used by India and some other countries as a surface-to-surface anti-ship missile. It has two firing modes. It has a horizontal firing mode, which we are not analyzing, and it also has a vertical firing mode, which utilizes small, perfectly timed burns from a module fitted on the nose. Once the two main orientation burns are done, the module separates, the rocket fins deploy, and the main booster then fires. To simplify this, we review the rocket as a simple rigid body, completing its motion in one plane, and only consider the two main orientation burns of the rocket as it goes from a vertical orientation to a horizontal orientation. The inputs of this system would be the force applied by the orientation thrusters at different times. The rocket sensors, actuators, and gyros read the orientation change due to the impulses, and will output the pitch rates and extra information so that the rocket can apply a second burn in order to stop the swing of the rocket and send it off at its correct trajectory. The sensors and gyroscopes in the rocket keep it correctly oriented as it travels from frame to frame. In a surface-to-surface application, the rocket will first have a relation to the ship's body frame as well as to its own. Once in flight, the missile monitors its orientation and location with respect to the ENU frame so that it can fly to its target. In summary, first the missile launches vertically with its main engine. Then thrusters provide impulsive forces to rotate the missile. Next, guidance computers take data to determine the current angle, and also then send signals to stop the rotation with another impulsive thruster. The engine then accelerates the missile to Mach 2.8 and cuts out. Computers then guide the missile to the target using the ENU frame. Also, the equations of motion that govern this rotation are the Euler angle rates of a rigid body. It is also a continuous system, as it is not limited to discrete values. This is also a good example of a closed-loop feedback system, as we correct the output constantly with the new values. This is also best modeled with the PID, as we want to accurately control the impulsive forces of the thrusters.